The next and final module in the passive treatment example is the wetland module. The first item is to input the design flow of 100 gallons per minute, which is the only active water quality and flow input parameter in the module by default. Next is to select the sizing method for estimating the wetland size based on either retention time, metal removal rates, or user-specified dimensions. For this example, we will use the retention time sizing method and set the default value to 12 hours based on the entered design flow. Here is what the wetland module looks like after changing these first two values for sizing. In the System Properties section, there are a few additional items to consider for a wetland. First, we will change the bottom length to width ratio to 4. Next, we will leave the boxes for inlet pool length and outlet pool length unchecked. This will not include an inlet and outlet pool feature at the upstream and downstream ends of the wetland. The next section is the layer materials and is where the user can adjust variables associated with each layer of the wetland. For the freeboard layer, we will increase the depth to 2.5 feet. The default values in the water and compost mix layers will be used, including any depths, components, and unit costs. The wetland rock baffles allows the user to incorporate rock baffles within the wetland area to promote flow distribution across the width of the wetland. By default, they are included, so if they are not desired, the user must uncheck the box next to Include Baffles. We will include rock baffles for the wetland and adjust the spacing to 50 feet and accept all other default values. Next, unselect the AMDTreat piping calculator box and select user-specified piping layout under the pipe layer. For the first pipe, enter the custom pipe name as 15-inch perforated pipe. Enter a length of 40 feet and a unit cost of $40. For a second pipe, enter the name as 8-inch solid pipe. Enter a length of 150 feet and a unit cost of $25. Other than non-woven geotextile separation material for placement between the excavated soil and the compost mix layer, no liner material will be used for the wetland. Adjust the non-woven geotextile unit cost to $3.50 per square yard. Under other items, we will utilize the default quantity and costs for all three structures, including a flow distribution structure, a water level control structure, and an outlet protection structure. The sizing summary for the wetlands module provides lots of detailed sizing information for the wetland feature, including the freeboard top length and width, layer volumes, wetland water surface area, rock baffle quantity and height, inlet and outlet pool volumes, and total water retention time. The example wetland we created has a freeboard top length of 185.46 feet, a freeboard top width of 53.37 feet, wetland water surface area of 10,111 square feet, compost mix volume of 322 cubic yards, of which 258 cubic yards is organic material and 64 cubic yards is limestone fines, rock baffle quantity of 3. Amount of limestone for the rock baffles is 150 tons, and retention time for the wetland of 11.4 hours. The capital cost section summarizes each of the primary components for the wetland feature and provides a total cost to construct the wetland based on the user-specified features and sizing criteria. The capital cost of the wetland is estimated to be $39,130. The annual cost section includes the costs associated with the operations and maintenance for the wetland. For the operations and maintenance, we will keep the default percentage of capital cost value of 5%, which results in a total annual cost of the wetland to be $1,957. Finally, the NPV for the wetland feature is $83,986 to maintain it for a 75-year period. Now, if we revisit the main user interface after setting up the three components of our example passive treatment system, we can see the capital cost, annual cost, and NPV values shown in the tile for each component. Also, at the bottom of the main user interface, there is a summary for the entire system showing the total capital cost of $214,954, a total annual cost of $15,639, and an NPV of $718,989. The project footprint in acres is also provided for all of the system components combined, and our system is estimated at 1.40 acres for the limestone bed, pond, and wetland. That concludes the tutorial for setting up an example passive treatment system in the AMDTreat software. Thank you, and please refer to the module tooltips and online help files for additional information.